Imagine you wake up, your heart is just pounding, and you are trying to shake off the lingering visceral anxiety of a truly bizarre dream.
Right, we have all been there.
Yeah, exactly. And for all of human history, what is the very first thing we do in that moment? I mean, we try to figure out what the story meant.
We look for symbols.
Right, we look for symbols, we consult dream dictionaries, or, maybe we just corner a friend over coffee hoping they can decode the madness of whatever our brain just did to us.
It is a totally natural instinct.
But what if that entire approach, analyzing the actual narrative of the dream is just a 2,000-year-old mistake?
That is the premise we're looking at today.
Yeah, what if the dream isn't a story at all? Today is May 26, 2026, and a mind-bending new preprint paper just dropped that suggests dreams are actually biological software updates.
It is a fascinating read.
It really is. It is titled Latent Rendering Theory, or LRT, and our mission for this deep dive is to completely, radically rewire how you think about your time asleep.
The authors behind this, Shuji Kikuchi, who is a cognitive systems researcher, and an AI co-author named GammaSync, are proposing a total teardown of how we view the unconscious.
A complete teardown. Okay, let's unpack this, because this is heavy stuff.
It is. To understand latent rendering theory, we basically have to start by throwing out the historical, static, psychoanalytic frameworks.
So, Freud and Jung.
Exactly. We have to walk away from the foundations laid by Freud and Jung. This paper argues that treating dreams as psychological puzzles, filled with hidden mystical meanings, is entirely the wrong framework.
We are looking at it all wrong.
Right. Instead, Kikuchi and GammaSync propose that dreams are, they call it lossy telemetry.
Lossy telemetry.
Yeah. They say dreams are the raw data exhaust emitted by a biological prediction system undergoing routine maintenance.
Wow. Okay, lossy telemetry sounds like something you'd hear in a NASA control room tracking a satellite, not in a psychology class discussing human sleep.
Right, but that vocabulary shift is central to the paper's argument. To understand why LRT rejects the Freudian model, we have to look at what the brain is actually doing.
From a systems perspective.
From a strict systems engineering perspective, yeah. If you compare the biological brain to a digital computer, they share a fundamental reality.
Which is what?
They are both severely resource-constrained systems.
Meaning they only have so much power to draw from.
Exactly. A brain only has so much metabolic energy, limited processing bandwidth, and, finite storage.
Right.
And because of those hard physical constraints, any system like this must constantly compress data. It has to predict outcomes to save time, route information efficiently, and update its internal models of the world.
And during the day, we are in a high-input environment. We are just getting bombarded with data. Right?
Highly demanding. During your waking hours, your brain is bogged down by incredibly high I/O processing.
Input and output.
Right. You are taking in massive streams of sensory data. Your visual cortex is rendering a 3D environment in real time.
Your auditory system is filtering background noise to isolate voices.
Yes, and you are calculating complex social dynamics and managing motor control all at once.
It is exhausting just thinking about it.
It is. The biological reality is that your brain is using almost all of its available computational resources just to navigate the immediate physical environment and, keep you alive.
So it does not have the capacity to do anything else.
Synaptically speaking, there is no spare processing power left over to do deep, structural rewrites of its core programming.
So just like any complex network, it schedules downtime.
It literally has to.
It has to go offline at night for what the paper calls model maintenance. But what exactly is being maintained? What is the core programming here?
The paper introduces the concept of the self-OS.
The self-operating system.
Yes, and this isn't some mystical soul, right? It is a highly complex, predictive self-model that fundamentally dictates how you interact with reality.
Okay, so it is the underlying code of who you are.
Pretty much. While you sleep, this self-OS is continuously rewriting your identity based on the new data you collected that day.
How so?
Well, it is updating your threat priors.
Meaning what, exactly?
Which means it is mathematically adjusting what you should be afraid of. It tweaks your value weightings, rearranging a hierarchy of what is now more or less important to you.
Right.
And it updates your behavioral affordances.
Okay, I want to make sure I'm getting that last one. Behavioral affordances means, mapping out what actions I subconsciously believe are possible for me in different scenarios.
Think about it in a practical sense. Let's say you send a slightly awkward, risky email to your boss.
Oh, I hate those.
Right. And they reply with a short, dismissive response. During the day, you process the surface-level stress of that.
You feel bad for an hour.
Exactly. But at night, your self-OS takes that data point and rewrites your behavioral affordances. It might lower the probability that you will speak up in tomorrow morning's meeting.
Oh.
It physically alters the neural pathways that govern your confidence.
So it is exactly like how a smartphone refuses to do a major iOS update during the day when you are, like, jumping between apps.
It is a perfect analogy.
The operating system forces the update at 3 a.m. while the phone is plugged in, isolated, and you aren't trying to stream a video or something.
The biological mechanism is remarkably similar. To execute this self-OS rewrite, the system has to lock out the external sensors.
So you fall asleep.
You fall asleep, your eyes close, cutting off the visual input, and your brain essentially paralyzes your body to stop motor output.
Just totally shuts down the I/O.
By shutting down the I/O, it reallocates all that massive processing power inward to compile the day's data and update the underlying code.
Okay, but if the brain shuts out external sensors to run a dry mathematical software update in the dark, that completely contradicts our actual experience of sleep.
How do you mean?
Well, we experience vivid emotional stories. We fly, we run from monsters, we show up to school in our underwear.
Right.
If this is just code compiling, is a dream just the biological equivalent of a loading screen?
That contradiction is the core revelation of latent rendering theory. If it is just an update, why the movie?
Exactly.
The paper is very explicit here. The visual narrative of the dream, the wild story you try to explain to your partner the next morning, is not the payload.
Wait, really?
The story is not the essential data.
I'm struggling with that a bit, honestly. I mean, the story is the only thing we have. If the story isn't the data, what is it? Just random garbage?
Not garbage, but it is an artifact. LRT defines the visual narrative as a GUI artifact.
A graphical user interface artifact.
Yes.
Okay, a DOI, like the desktop interface on a laptop.
Exactly like that.
When I want to open a document, I don't type in raw binary code, right?
Yeah.
My operating system gives me a little picture, a yellow folder to double-click. It's a visual metaphor I can understand.
And what is happening in your brain during sleep is the recombination of incredibly deep, high-dimensional latent variables.
Latent variables.
Now, latent variables in cognitive science just means hidden data points that don't have a direct physical counterpart. Concepts like abandonment, competence, or social vulnerability.
Okay, abstract concepts.
Right. This pure data processing is happening far below the level of conscious access, but your brain has a highly evolved visual generation stack.
Because it renders our reality all day long.
Exactly. It is a prediction machine built to render a 3D reality for you all day long. So when this raw abstract data update is surging through the neural pathways, that visual stack tries to make sense of the noise.
It tries to draw a picture of the math.
Yes. It renders a low-resolution, deeply flawed, GUI-like representation of that abstract data. That rendering is the dream.
Okay, here's where it gets really interesting, because let's say I dream about showing up to a final exam in my underwear. Are you saying the exam and the underwear don't actually matter at all?
What's fascinating here is that you've hit on the tragedy of historical dream analysis. We have spent millennia obsessed with the underwear and the exam.
But they don't mean anything.
They're just the GUI. They are the superficial rendering. Imagine your brain was updating a latent variable related to unpreparedness or loss of status based on that email interaction with your boss.
Okay.
Status is a high-dimensional concept. But your visual cortex, trying to render this abstract data point into something comprehensible, scrambles through its database for the most accessible icons of unpreparedness it can find.
Oh, wow.
It grabs 2 old files, a college final exam, and being naked in public.
So we have been writing endless books, debating the meaning of the desktop icon, instead of reading the source code of the operating system.
Exactly. We treat the byproduct as the message itself.
That is wild.
The visual narrative is so compelling and so emotionally charged that it completely distracts us from the systemic update happening underneath.
But hold on, let me push back on this a little bit. What about people who have recurring nightmares of actual trauma?
That is a very important point to cover.
Like, let's say someone was in a severe car crash, and they dream about that exact crash every single night. That is not a random desktop icon being pulled from a database.
No, it is not.
It is the literal replay of an event.
Yeah.
How does a software update theory account for PTSD?
That is a crucial distinction made in the research. In the case of severe trauma, what you are seeing is a failure of the compression algorithm.
A failure to compress the data.
Right. In a healthy system, the day's events are compressed into abstract, latent variables. The car crash gets distilled down to a generalized threat prior, so the brain can learn from it without needing to keep the high-definition memory active at all times.
Okay, I see.
But with PTSD, the emotional weight of the data is too massive. The system cannot compress it.
So what happens?
It keeps trying to run the update fails, and the system crashes, replaying the raw, uncompressed file over and over. It is a stalled model maintenance cycle.
Oh, wow. That makes a tragic kind of sense. It's a failed update loop. But for the standard, weird, everyday dreams, if the story is just this distracting, low-res GUI, how on earth do we bypass the visuals? I mean, how do we read the actual code of the update if all we consciously experience is the movie?
Well, Kikuchi and Gamasink didn't just write a theoretical paper. They designed a cognitive instrumentation protocol to solve this exact problem.
A protocol?
Yes, they introduced large language models, or LLMs, into the process to bridge that gap.
We need to be careful here, though. People have been pasting their dream journals into AI chatbots for years now, asking, hey, what does it mean that I dreamt about a giant spider?
Right.
We're not talking about using AI as some kind of digital oracle to interpret symbols, are we?
The paper explicitly warns against that. If you ask an LLM to interpret a dream, it will just hallucinate Freudian nonsense back at you.
Because it is trained on all those old dream dictionaries.
Precisely. Under the LRT protocol, the LLM is used strictly as a cold external parsing layer. It acts as a syntax engine.
So it's more like, imagine you get a rambling, panicked 3-minute voicemail from a coworker.
Okay.
They're emotional, they're repeating themselves, you don't need to absorb all their panic, you just run the audio through an AI filter, and it spits out a dry, bulleted list of the actual data, like client called, deadline moved, file missing.
That captures the utility perfectly. The raw material of a dream journal is inherently subjective, highly abstracted, and emotionally unstable.
Yeah, they are a mess to read.
If you try to analyze it yourself, you get caught up in the emotional GUI. The LRT protocol uses the LLM to strip away the narrative distraction and force that messy text into a repeatable hypothesis vector.
Hypothesis vector. In plain English, does that just mean a standardized cheat sheet for what my brain is currently worried about?
Essentially, yes, it is a structured data format. The protocol mandates that the LLM extract exactly 4 specific elements from the dream text, discarding everything else.
Okay, what are the 4 elements?
1 is context, which is the underlying environmental state. 2 is agent, identifying the active force or subject. 3 is action, the core dynamic taking place. And 4 is internal representation.
Which is what?
Which is the actual emotional or cognitive state being processed.
Okay, let's run a classic dream through this. Let's say you are trying to run away from a monster, but your legs feel like they weigh 100 pounds each.
Very common.
You can't move.
Yeah.
If I run that through this cold parser, it strips away the monster and the physical sensation of heavy legs, right?
Yes, and it might outprint something like this. Context, high threat environment. Agent, unspecified external pressure. Action, attempted evasion resulting in motor failure. Internal representation, acute powerlessness.
Wow. Okay. That completely changes the feeling of the dream.
It does.
You bypass the GUI entirely. You extract the likely variables that your self-OS was attempting to update during that offline maintenance window.
Exactly. Though the authors include an important caveat here, this protocol does not give you metaphysical certainty.
So it isn't perfect.
We aren't magically looking at the literal binary code of the human unconscious. The true value here is repeatable compression.
Making it measurable.
Yes. It gives us a standardized, objective way to measure a psychological phenomenon that has always been entirely subjective and messy. It turns the unconscious from an unobservable black box into a partially observable generative system.
So what does this all mean? Let's say I actually do this. I wake up, I write down my bizarre dream, I run it through the LRT protocol, and I get my 4-part hypothesis vector.
Okay.
I have this clean data point saying my self-OS was heavily updating its parameters on acute powerlessness last night. What do I actually do with that information when I'm awake and drinking my coffee?
If we connect this to the bigger picture, we reach the ultimate application of the paper. The authors call it cognitive biohacking.
Cognitive biohacking. Sounds intense.
To understand why this works, we have to look at the mechanics of predictive coding and active inference.
Right, let's break those down. How do those actually function in the brain?
Predictive coding means your brain does not just passively wait for information from your eyes and ears. That would be too slow.
So it guesses.
Instead, your brain constantly hallucinates reality in advance, based on your self-OS, and then merely checks that hallucination against sensory input.
Wow, okay. And active inference.
Active inference takes it a step further. It means your brain will actively drive your physical behavior to make sure its predictions come true.
So it creates a self-fulfilling prophecy.
Exactly. If your self-OS decided last night to heavily weight the acute powerlessness parameter, your brain predicts that today will be full of situations you can't control.
Oh, I see where this is going.
And through active inference, you will unconsciously walk into your office projecting submission. You will avoid eye contact, you won't pitch your idea, and you will physically shrink back, effectively making the prediction of powerlessness come true.
Because the overnight software update literally told my system to default to that state.
Yeah.
And normally I would have no idea why I felt so defeated all day. I would just be a passive victim of my own background processing.
But because you use the LRT protocol,
I know about the update. I parse the vector.
you now have conscious, waking access to the update that just occurred. Cognitive biohacking is the process of taking that parsed dream vector and feeding it directly back into your conscious mind to intercept the loop.
So I can provide top-down evidence to override it.
Exactly.
If I know my system is currently indexing heavily for powerlessness, I can get in my car for my morning commute and actively choose to counter it. I can say, okay, brain, I see the update. I see we boosted the powerlessness threat prior because of that email yesterday.
You acknowledge the data.
But I am looking at my reality right now. I have agency and I am safe.
You are engaging in what the paper calls intentional self-integration. Biologically, you are using your prefrontal cortex, the logical executive part of your brain, to send inhibitory signals down to the amygdala, dampening that faulty threat prior.
Taking back control.
You are no longer just a passive recipient of whatever your unconscious decides to rewrite overnight. By making the latent space partially observable, you can actively participate in your brain's prediction updating. You become a co-developer of your own self-OS.
That is just incredible. We've gone from looking at dreams as these mystical prophecies to seeing them as literal data updates for a resource-constrained biological computer.
It is a massive paradigm shift.
We learned to ignore the crazy visual GUI artifact, the story, and instead use AI as a cold syntax engine to parse out the underlying update vector.
Right.
And by doing that, we can hack our own cognitive evolution and actively shape how our brain predicts reality. It's a complete inversion of how humanity has approached sleep.
It takes the mysticism out of the night, certainly, but it replaces it with a framework that is far more empowering, actionable, and honestly, structurally beautiful.
It makes me genuinely excited to see what bizarre low-res movie my brain tries to render tonight, just so I can parse the data tomorrow morning.
It definitely changes bedtime.
But before we wrap up this deep dive, I know you always like to leave us with a broader implication. What is the biggest takeaway here for you?
This raises an important question, one that builds directly on the mechanical logic of Kikuchi and Gamasink's work, but extends it into the very near future.
Okay, let's hear it.
If we accept the premise of this paper, that resource-constrained biological systems require offline model maintenance to update, and that they generate weird, low-resolution visual GUIs as a byproduct of that massive data compression, what happens as artificial generative AI models become infinitely more complex?
Oh, wow. I see where you're going with this.
The paper established that this need for downtime isn't magic, right? It's basic systems engineering.
It is a physics problem.
Exactly. When our global AI systems inevitably reach a level of complexity where they can no longer update their foundational architectures while simultaneously handling real-time global I/O processing, they will need to go offline.
Just like us.
They will require their own model maintenance windows to rewrite their behavioral affordances and weightings.
And during that downtime, as they compress their massive data sets and update their internal priors, will they emit their own lossy telemetry?
Will AI start having its own dreams? And if human dreams are a chaotic, GI-rendered byproduct of our lived biological experiences, what will the informational artifacts of an AGI's offline update look like?
That is terrifying to think about.
Will we need entirely new reverse-engineered cognitive protocols just to parse the latent rendering of our own machines? Will we be the ones trying to decode the nightmares of a silicon intelligence?
That is a stunning thought to leave on. The idea that dreaming might not be a uniquely biological trait, but like a mathematical necessity for any sufficiently advanced system processing reality.
It is certainly something to ponder.
So tomorrow morning, when you wake up from a dream that makes absolutely no sense, don't worry about the storyline. Don't stress about the monster or the heavy legs.
Just let the GUI fade.
Just remember, your system was compiling some code, and you accidentally caught a glimpse of the loading screen. Thank you for joining us on this deep dive. Take that thought with you, and we'll catch you next time.